Hello and welcome to this edition of Tomorrow's Tech here in the Department of Mechanical Engineering at University College London. Today I'm going to be talking to one of our PhD students, Anastasia. Anastasia, tell me a bit about what you do.
My project is to understand how fluids behave because these can help make oral health products better.
And it all starts with some things we've got in our kitchen cupboard that behave differently. We've got some honey and some water here. Tell me about the difference between those two.
As you can see, if I try to pour water, it flows very easily. So this means that it has a very low viscosity. And if I try to mix it or do something, its behavior doesn't change. This means that it's a Newtonian fluid. If I try to pour honey, then I might face a resistance. Honey has a higher viscosity.
So we know that water is very runny and that honey is very viscous, and they're different fluids. But there are some fluids that can behave in both ways depending on what you do to them.
And a very simple example of this kind of fluid is a toothpaste that we every day use. The speed that we brush our teeth has an impact on how it will behave either as a solid or as a liquid. For example, I have some toothpaste here and I can show you that if I keep it like that, it doesn't drop down, but when I squeeze the tube, a nice ribbon of toothpaste is a solid on the toothbrush. While when we are trying to brush our teeth, which means that we apply some force on it, it starts to behave like a liquid so that it can satisfy consumer needs and also let the active ingredients to go on the teeth and help the health of the teeth.
The toothpaste doesn't change, but when you hold it in the tube, it's like a solid. When you squeeze it, it becomes like a liquid just while it's moving, and then it becomes a solid again, and then you brush your teeth and it becomes like a liquid.
Yeah, it's a matter of the ingredients that it contains that help it to change its form regarding on what we do to them and how we do it, the speed we do it, and the length of the time that we do it.
So this is a special class of materials because the way that they behave depends on how quickly you push them.
Right. This kind of fluids are called Non-Newtonian. This is very important because if we first understand how the separate ingredients of a toothpaste work, then we can combine all of them and provide products with better properties, as well as introducing new manufacturing processes that will be less time and energy consuming. The most important ingredients of a toothpaste, in my mind, are four. First, we have a matrix that is formed without water and mostly is glycerol.
So the glycerol here that's what everything else is in. That's the sort of container.
Yeah, this is the main matrix. And then, in order to introduce this non-Newtonian behavior, we have some polymers, which we can imagine them as little chains that form networks, and the other ingredients can be entrapped, encapsulated in this network so that they can be there till we apply a stress. And this is mainly the matrix that we use. And we have abrasive particles as cleaning agents, and these particles are strange in morphology, and there are also some other types of particles so that we can control the thickness of our product. The other ones have a similar morphology, but they are there as thickeners. And thickeners can also help to keep the active ingredients within the matrix so that they are released in a controlled way when we brush our teeth.
So we might think that toothpaste, we've all been using toothpaste for years, that toothpaste is all sorted out, but actually you're saying toothpaste could get even better.
Yeah, the oral health industry today worth almost 1 billion in the UK every year. If we find a way to understand how the ingredients of oral health products behave on their own, we can make, of course, better toothpastes. So the better we make these products, we improve both the industry and the health of consumers.